The function f, defined for whole positive numbers, satisfies f of 1 is equal to 1, and also the rules f of 2n is equal to 2f of n, and f of 2n plus 1 is equal to 4f of n, for all values of n. How many numbers n satisfy f of n is equal to 16? 3, 4, 5, or 6? So my first thought here was to just start computing all values of f for, we're given f of 1. We can use the rules to compute f2, f3, f4, f5, and so on. But it might take a long time to figure out, and we may not really ever figure out how many values satisfy f of n is equal to 16. Another way of doing this is to just let f of n equal to 16, and then substitute that into the two rules and figure out the other values of the argument of the function where this has to be equal to 16. Okay. How am I going to do this? Is it best to just start writing values out? I'm going to start just by writing out a few values. See if maybe there's some kind of little pattern or something like that we can get. You write the rules down here so they're easier to see. So f of 3 is going to equal 4. F of 4 is going to be also 4. F of 5 is it also 4? Yeah. F of 6 is 2 times f of 3. Just make sure I haven't made any mistakes yet. F of 4, so that should be 2f of 2. Okay. F of 5 should be 4f of 2. Maybe that's a mistake. F of 7 is equal to 4 f of 3, which is 16. F of 8 is 2 f of 4, which is 8. F of 9 is equal to 4 f of 4, which is 16. F10 is 2 f of 5, which is equal to 16. So I found 3 values here already. That's the first option in the question. I'm not really seeing any pattern. Obviously, every value of the function is going to be a power of 2, but seems to be jumping around. It's not even necessarily increasing, right? We have a part here where the function is decreasing. I'm just going to continue here for a little bit. So we're never going to get a number. Oh wait, we might still get a f of 16, right? F of 14 and 15 will be 32 and 64. This is the last one when multiplied by 2 or greater, that'll give us 16. So f of 14 will be equal to 32. F of 15 will be 64. And f of 16 will be 2f of 8, which is 16. And now, you know, for the rest of this list, as I complete these, I'll only ever be looking below here. So we'll always be multiplying by, 16 by something greater. So how many values of 16 do we have here? 1, 2, 3, 4, 5. So I guess the answer is C, 5. There's probably a much more elegant way of doing this. Even though my first instinct was to start computing these, I also didn't think that was going to be the most elegant way of doing it. I was hoping to see some kind of pattern after doing this for a couple values. And I suppose, we can combine this relation to see that f of n plus 1 is equal to 2 f of n when n is even. Is there anything we can say when n is odd? Not really, right? Yeah, this is a factor of 2, 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 factor of 2. The next one should also be, but yeah, maybe I could have figured this out quickly by only filling in I'm not sure. I can't just use one of the rules. I can't just use this to fill in half of the yeah. I'm not sure what what a more elegant way of doing this is, other than just filling in this list and realizing that once you get to here, you can stop, because you're never going to look back at this part of the list again. Yeah, so 5 values of n that give us f of n equals 16. If I have more to say, I'll put it down in the description. Thanks for watching.